Howdy and good day. Today in Algebra, we'll be covering PO4, multiplying and dividing integers and fractions. A common theme that we're going to see through our journey in Algebra here is that oftentimes it's more fun to multiply and divide things than it is to add and subtract things. Because if you think back to yesterday and all the rules that we had for adding and subtracting fractions, if you remember what you've learned about multiplying and dividing fractions, there's a lot less, right? Not to skip ahead here, but what don't you need when multiplying and dividing fractions that you do need when adding and subtracting? Those common denominators, okay? And when we get to combining like terms and combining radical expressions, some of these other things that are coming up here, it's actually kind of nice to multiply and divide. There's less rules, less things to keep track of. And we'll see that immediately here with integers because there's nothing really fancy about them. Whoops. If you, those multiplication tables that you had to memorize when you were in third grade, fourth grade, whatever it was, 8 times 3, you know that's 24. So the fact that one of those is negative, 8 times negative 3, how does that affect your final product? 2 people know? No? 3? Griff.
It's negative?
It's going to be negative, okay? And so this table here kind of outlines those sign rules for you. It is a key point, so kind of go on a help sheet, since obviously you will not be able to use a calculator on this section of the test. So if you have a positive value and you're multiplying or dividing it by another positive value, the result is a positive value. If you have a positive value multiplied or divided by a negative value, your product or quotient is going to be negative. And because of the commutative property, we know that something like positive 8 times negative 3 is the same thing as negative 3 times positive 8. It's going to give us the same product. You can multiply things in any order. So if you have a negative multiplied or divided by a positive, you're still going to get that negative answer. Okay? And then finally, a negative multiplied or divided by a negative gives you a positive, similar to what we saw yesterday with adding and subtracting, that when you subtract a negative number, it's actually adding it. So general rule of thumb here, okay, if your signs are the same, either both positive or both negative, your answer is going to be positive. If you have one of each, if they're different, then it's going to be negative. Okay. So something like negative 120 divided by negative 6, you know that your quotient is going to be positive. You can almost just ignore these signs, they'll cancel out anyway, and it becomes 120 divided by 6, which is 20. Okay? So, as long as you know your sign rules and follow the sign rules, then you should be okay. Questions on integers? All right. On to, yes?
Yes, I actually do have a question.
Yes, go ahead.
So, when you get into fractions with when you get into fractions with these and you have negatives, and you do that times a positive, what would you get? Like, would it still remain negative?
Good thing we're going to talk about fractions next.
Oh, okay.
Yeah. I'll leave in suspense for about 15 seconds, and then we'll go in there. So with fractions, we'll start with the signs here. So Luke is asking, ask your question again, Luke.
So if you did a negative times a positive, like that first question there, would it still remain a negative, or would you have to turn into a positive?
Well, you've got a negative term, negative 13/12 times a positive term, 3/5. Whether you're dealing with integers or decimals or fractions or variables or whatever, a negative times a positive is going to give you a negative. Okay? So with negative 13/12 times 3/5, what is our process for multiplying fractions? What is our process for multiplying fractions? Linnea? Straight across. Common denominators? Nope. Okay? Across we go. And we end up with 13 times 3, which is 39, and 12 times 5, which is 60. And it's going to be negative because of that negative times a positive. Okay? Of course, this is not going to be our final answer because we need to simplify. And so what's the greatest common factor of 39 and 60? What can we divide by? Colin? Divide by 3. And so we get a final answer of negative 13/20. Okay. The last class asked if you have to wait until the end to simplify. Can you simplify at the beginning? Of course. Okay. If you end up needing to simplify, whether you do it at the beginning, the middle, or the end, doesn't really make a difference. It's kind of a personal preference thing. As long as you do it, you'll end up with negative 13/20 as your final answer. Luke.
Another question.
Yeah.
If you have the same common denominator, could you just leave it like that?
With multiplying?
Well, yeah, with multiplying or division. So for example, that next one, 9 times 5.
Yeah.
Could you just leave those and keep it at 9?
No. Let's talk about that next one a little bit. First of all, you cannot just take the 1/9 and the 5/9 and multiply them and then stick the 2 on at the end. That's not how mixed numbers and fractions work. You do need to convert this to an improper fraction. So you get 19/9 times 5/9. And Luke's question is, since the denominators are the same, do we just keep the 9 when we get our answer?
Yeah.
No, not with multiplication and division. Okay, you must multiply numerator by numerator and denominator by denominator. So what we get when we do this, going straight across here, 19 times 5 is 95. 9 times 9 is 81. There's no common factor with 95 and 81, so you could leave it like that if you wanted to, or you could convert to the mixed number 1 and 14/81. And this raises up an interesting math question here. We're starting with 2 wholes and then a little bit more, right? 2 and 1/9. We're multiplying, but the answer we get is smaller. It's only 1 whole and then 14/81. How is it that when you multiply, you get a value that's smaller than what you started with?
That's kind of weird.
It is. That's why we're talking about it. Anyone know why you would start with a value, multiply, and then get a smaller value as an answer? Olivia? No, not because we simplified. Luke? What do you mean converted? No, because we converted to improper fraction? Or no? These two values here have the same value, just written in a different form. So we still started with more than 2 wholes, and we ended with between 1 and 2 wholes. Okay, so why did that value decrease when we're multiplying? I thought multiplied meant you get bigger. Yeah.
Both fractions that are over 9 aren't equivalent. Like one's smaller, like 1/9, and the other one's 5/9.
No, not because they're not equivalents, but it has to do with the fact that it's a fraction. Okay, tell me about the value of 5/9. Less than 1, greater than 1, or equal to 1? Grayson. Okay, and is that less than 1, equal to 1, or less than 1? When you multiply a value by something less than 1, you are multiplying by something less than 1 whole, which means you're taking a fraction of it, a part of it, and thus you'll get something smaller, right? 8 times a half is 4, because you're only taking half of 8. When you multiply a value by something equal to 1 whole, it stays the same. You learned that back in 3rd grade when you first learned to multiply. And when you multiply something by a value greater than 1, that's when it increases. Okay? So it's because 5/9 is less than 1 whole, that's why we get a value that is less than what we started with. Let's talk about dividing fractions. 9/10 divided by 8/7. I'm on the second one in the second row there. Give me one method that you've heard before to divide fractions. Catherine? Keep, change, flip. Last class was the first time that I'd heard that method described as keep, change, flip, and I love it. I just always call it the flipping method. But keep, change, flip makes sense because you keep. It made me hungry. Yeah, no, that's what I thought too. You keep that first fraction, The change refers to the operation. It changes from division to multiplication, and then that second fraction is flipped, right? 9/10 times 7/8. And now that we've done that, we've rewritten this expression to be multiplication. Our process goes right back to what we did up top, right? We're multiplying straight across. 9 times 7 is 63. 10 times 8 is 80. And since we can't simplify that, then we know that we're done. Okay? So that method works very, very well. What's another method you can use that's maybe more mental math, doesn't involve flipping that second fraction? Max? You still end up with the same result, but you don't flip that second fraction.
Write the proper and improper fractions and use cross multiplication.
Yes, cross products, right? You keep the expression written the way it is, 9/10 divided by 8/7, and instead of flipping the second fraction and multiplying straight across, you just know, oh, okay, I'm going to use cross products. I'm going to multiply the numerator of one by the denominator of the other. And doing that, you still end up multiplying 9 by 7. That gives you 63. Denominator of one by the numerator of the other, 10 times 8. Same thing we did here. And we still get 80, or 63/80ths as an answer. Okay. So, yeah, that's kind of more of a mental math way to do the keep, change, flip method. The result's the same, so which method you do doesn't really matter to me. Christopher.
So for multiply, when you multiply the fractions, why can we just use cross products?
Cross products for multiplying fractions doesn't work. Okay? The cross products method is used for dividing fractions. For multiplying fractions, first convert to improper fractions if you have to, and then multiply straight across. For dividing fractions, you've got either cross products or flip the second fraction and then multiply, or the keep, change, flip. But cross products is not for multiplying fractions, it's for dividing fractions. Okay? Questions on that? Should still be in the review phase, but maybe some, it's just a good thing to practice, make sure that we have it down. No?
No.
Sweet. All right, your homework is to finish PO4. We'll start with PO5 on Monday. That is how you math.